Yeah. My name is Jason Dover, Vice President of Product Strategy at Kemp Technologies. I've had a chance to speak with at least a couple of you in other forums. For those that I haven't, great to meet you and look forward to our engagement today as well as later on in the day. A small bit of background about myself. I come from working in the enterprise IT space, predominantly in the financial industry. So as an example, I worked at New York Stock Exchange in the mid-2000s when they were going through integrations with Ames, Life, and Euronext. And I was a key part of the messaging, directory services integrations, and along with another brilliant engineer named John. And just was kind of reflecting back on that time. The interesting thing that I found was that outages were almost the easy part, right? If you had a catastrophic outage, it was easy to explain it to the business. Right, we had a catastrophic failure with X in Sector 5. We're working on it. We'll get you an update as soon as we can. The things that were really hard and that really gave us headaches, though, was when there was simply application experience degradation. Right, so email fell within my remit. If you had the CIO flying to APAC and she noticed that emails were coming into her BlackBerry, and this is early 2000s, out of order from what she was seeing on her Outlook client, and you needed to troubleshoot it, that was a real challenge. It gave you a headache. Or let's say the legal team was trying to log into their legal discovery service, which was reliant on your LDAP infrastructure, and they were getting unexpected results in how they were getting access rights to that ecosystem. Those type of things was much harder to troubleshoot and much harder to explain when you had to deal with them over an outage. And that's why I'm really excited to be at Kemp now on the kind of other side of the fence, on the vendor side. When you think about load balancing technology and where it sits in the stack, right, which we'll talk about and visualize in a moment, but at that key integral point between users and the application services, it's in a prime location to surface insights about what's going on with the application experience that customers are having, as well as to do something about it, because we're an active participant in the traffic flow as well. Even beyond that, just by how you architect the ecosystem in the first place can help to optimize the application experience that customers have. And so that's really our focus, is looking at load balancing, but through the lens of how it can help customers with application experience. Look forward to chatting about that over the next few minutes. A bit of background on Kemp, just in case there are some folks that maybe are less familiar. As already highlighted, we're a load balancer vendor primarily around since the early 2000s. When we first came into the market, our focus was really addressing a part of the market that was underserved. If you rewind back, now it's the olden days, the early 2000s, you didn't really have a lot of offerings and options. On the one hand, you had open source software-based solutions that were not very mature, not very robust. On the other end, you had a couple of select vendors that came to market focusing on custom hardware and silicon, very expensive and challenging to use products. And so if you had a customer who maybe had some budgetary constraints, but they had high-end requirements, there wasn't really a good option that was available to them. And so we sought to address that part of the market. We did that by taking a software-first approach. Marketing folks today would call it disaggregation, right? I just say that we built some intelligent and amazing software that can optimize x86 COTS platforms. In some cases, we did leverage ASICs for enhancing our performance, but that gave us a model where our products were not very tightly tied to the underlying hardware that they ran on top of. And so you fast forward some time, right, later in the 2000s to when this thing called virtualization, when this thing called cloud started to become a common part of our vernacular, we were already well positioned to take advantage of those trends. And so we were one of the first load balancer vendors to have a virtual product. We were the first vendor to have a product inside of Microsoft Azure as well. And most of our growth over the last few years has been fueled predominantly by software and by cloud. I talked to some of you already. I'm based out of New York, but we're a global company, as you can see, some of our key offices. Imagine that most folks are familiar with a load balancer and what it does, but it is somewhat of a niche technology, so we'll spend just a moment or two talking about some of the basics, the 101s. This shows a kind of basic diagram of where it sits in the flow. You have clients, you have application servers, and you have a load balancer that manages the traffic flow from those clients to those application VMs or services and servers. If you wind the clock back, the primary focus initially for this would have been really about scale, right? I've got a web server, I've got an application, and I get to the maximum capacity of what a single VM or a single server can do. Now I need to add a second, a third, a fourth application VM. I want that to be transparent to the customers that are accessing it. And so I put the load balancer in between. That maintains the namespace, it maintains the termination endpoint, and I just add those additional servers behind that load balancer. You fast forward to today, that's still a requirement, but it's less so. I mean, with the enhancements and advancements of x86 and virtualization, you may be able to run an application for your entire organization on a single machine, whether it's virtualized or hardware. But you have multiple, primarily for scale, for high availability, for resilience. Now again, given that point that the load balancer sits, point of ingress for all client requests, typically, outside of some edge cases, the point of egress for all server responses, it's also a place where you often will consolidate some security functionality. If I want to do anything smart with an encrypted traffic flow, what am I going to have to do? I'm going to have to decrypt and unpack that traffic to look inside of it. Maybe header injection, maybe content swishing in a case of microservices and what have you. And so it's a place where you will naturally start to consolidate some security services. As an example, web application firewall, IPS, endpoint authentication, SSO. These are all the things that have started to become consolidated in what a load balancer is expected to do. And so you'll oftentimes hear today, you may hear me say it too, the word EDC, or application delivery controller. That's just a fancy word for an advanced load balancer. They really are one and the same, but this essentially covers what a load balancer is intended to do. How do we do it? We've got 3 core foundational products that allows us to address those requirements. Just want to give a bit of a baseline here because we're going to talk about these components at great depth, and I'm going to demonstrate some of them to you as we go along. So LoadMaster is our load balancer, which we just talked about. The second piece of our product suite is Kemp 360 Central. This is our centralized management, orchestration, automation framework, helps with provisioning, gives visibility, some monitoring and analytics. And the third piece is Kemp 360 Vision, which is a product that provides predictive analytics and insight for a customer ecosystem. At a high level, how it works, an agent gets dropped inside of the customer's infrastructure, a lightweight VM. That VM captures insights from the load balancer, from the applications that's being load balanced, and from the network, runs that through a rules processing engine. The goal of it is to surface impending issues or things that are starting to develop and that could result in application experience degradation before they actually happen. And we'll dig into that a little bit deeper as we go along. But this basically gives a baseline, who Kemp is, what we do, what our products and technologies are all about. Any questions so far? Okay. I'm Jason Dover, Vice President of Product Strategy at Kemp Technologies. In this section of our network field day discussion, we're going to talk about some of the common challenges that are faced in enterprise IT. We're looking at this from the unique lens of the load balancer, but really these are fundamental challenges, right? This just shows a high-level representation of the traditional way that we do data center planning, and by extension, load balancer planning. And that way is that we think some point in the future, could be a year, 3 years, 5 years, what have you, and we say, what's the maximum capacity that I'm going to require over the life cycle of this infrastructure or this product that I'm putting in place? And so in the case of a load balancer, I say, based on all the applications I'm going to put on, number of users, how much throughput, how much SSL, how many connections am I going to have to handle at the height of busyness inside of my ecosystem? And for the sake of this example, we may say 10 gigabits per second. But we oftentimes get that wrong, right? This is what your usage pattern may actually look like. And you're going to wind up with times where you have peaks and troughs. You're going to wind up with times more often than not where you're actually underutilizing the infrastructure that you've set up. And in those cases, you've got funds locked up in that infrastructure that could have been allocated elsewhere. You've got the other case, which is the worst case, where you're under-provisioned. Because what do you have to do then? Well, when you're under-provisioned, you wind up having to go and rip and replace what you have and put something in of greater capacity. but that may not be a sustained state. Time may go on. You may offload certain applications. You may outsource departments. There may be cuts. What have you, your utilization requirements can go down. So this winds up being a typically expensive undertaking and a challenging undertaking. It's just the way we've always done it, so people just expect that this is what you have to do. This is further compounded by the types of usage patterns that we see today. You have this, what I call on-off demand use case, where I may need capacity for a given period of time, and then I don't need it anymore. It's not that it just goes down to a low amount, but it may go down to zero. This could be the case of, let's say, with DevOps processes, where I'm doing some testing, I'm just evaluating things, HR, business continuity planning. The point is that to plan for this with the traditional approach, I need to buy the infrastructure. Now, I may turn it off, but I would need to have it available for when these events occur. We have the other one that we kind of showed just in the previous slide about variable usage patterns. I could be an e-commerce type organization where I have some seasonality, right? I do campaigns, there's holidays, what have you, or my usage spikes up. Again, if I want to be prepared for that, I need to over-provision. Over-provision is a normal part of our dialogue when we're talking about networking. But it shouldn't be, and we'll talk about why not in a minute. And then the last one, this is maybe what people hope for or plan for, but it often doesn't net out. But it was where you just have this nice steady growth that goes as your business grows. And this is what IT normally has in mind when they think 3 years out of what they need to scope. But as we just saw, you don't always get that right. Yet there's another bit of complexity, another challenge that comes into play. And that's the actual application deployment patterns that are emerging today. Of course, virtualization has been around for quite some time, but you then start to introduce cloud. We're not just talking about public cloud, but we're also talking about cloud operating models, which equally applies inside of an on-premises ecosystem. The idea of doing just-in-time delivery of services, perhaps some element of self-service, and again, not needing to plan so far out about what the capacity you're going to require. Not everyone's seeking to be a Netflix or a Google, but there is some adoption that's starting to happen with microservices and with containers. There was a report by another tech firm, and they reported, I think it was Pivotal Cloud Foundry, in fact. They mentioned that in 2017 was the year of the container. But the interesting data behind that was that the average enterprise has about 1.5 containers, right? So it is starting to take shape, and some organizations are further along than not. The point isn't so much the technology, though. It's really much more about the principles. The principles behind it is to say that you're going to build your software, build your application, so that you can have greater agility, right? You can do updates more frequently. You may break out the application in a way that different departments can work at different clips. This kind of falls apart, this concept of these small blast radius, if you follow the traditional approach of load balancing, which is to consolidate as many applications and workloads as you can behind a single hardware instance. You've kind of undone all the work you were seeking to do of having small blast radius, because that single load balancer serves as a point of failure. It means that you cannot customize the requirements of that load balancer to the individual applications and services. And there may just be different requirements for different parts of your application ecosystem. This is really what's driving the requirement behind per-app load balancing, which is something that we've been at the spearhead of. And the concept here is basically you should have the flexibility to deploy a load balancer for each and every application and each and every service that you have. Now, you may not actually do that in practice because it may make sense to consolidate some of them. But if you just think about the constraints we talked about, small blast radius and not having the single point of failure in the load balancer as an example, equally being able to do just-in-time delivery of services. If you had the facility to do this, this would address some of those challenges. I can imagine, I see people, different looks on their face. I see some guys nodding, some people with question marks. There's probably some questions that come up. I'll preempt some of the questions that we've heard when we've talked about this concept with customers. There's kind of two factors. One is the commercial aspect, right? Because this sounds like it could be pretty darn expensive. If I'm going to deploy a load balancer for every app or for every service, well, the way that we price and license load balancers today just doesn't work, because I price based on the amount of instances that you have and the capacity of each of those instances. there's also a complexity that comes into place from a technical perspective, right? If I'm going from 2 big hardware-based multi-tenant load balancers to 20, 40, 200 virtual instances, well, how am I going to manage it? How am I going to get consistency of state? And so there's kind of these 2 aspects that needs to be checked off for this to actually work. We're going to talk through for just a minute or 2 the commercial aspects, and then we'll do some demonstrations to highlight what we've done to address the technical bits as well.